I think what we should really realize here is that what we built is quite amazing. And I'm very proud of it. And we almost take it for granted that we can do these type of studies this quickly, and we can build an automatic protocol, we can build an automatic like a result document that's like the start of a paper, we can do external validation. So, and this is just the start of it. If we can make this now grow further and run it on many prediction problems, I think we can really move the prediction field forward quite a lot. You just learned actually the first step of Bayes-Level prediction. And I would really advise you to of course, read our paper, but also play around with it. And as you've seen on that initial landing page that the Amazon people created for you, there's an option to keep these VMs alive for a bit of time after the tutorial. So you can send an email to James Wiggins, is at the bottom of that page, to ask if you can get some credits to get access to the VM for a longer time. So please do that. There's a limited amount of those tickets, but if you are really interested, you can get that and you can play a little bit longer on the VM, so on the Atlas and on the R server. So please do that if you are very interested. So what's next? I hope we make clear with the exercise that Ross did that following some guidelines of reporting prediction models is important, and we should try to all do that. And we try to enforce tripod through the framework that we've been building, like the automatic creation of the document follows tripod very nicely. But please keep that in mind, because we really think that we cannot move forward without following these type of guidelines, and also making sure that we share the model and we're able to reproduce it on our data. And we facilitated that through our framework quite nicely. And as I said, this is just the beginning of it. Of course, if you use the package, please cite our paper, and that makes sense. I also got a couple of questions of people, how do I join this? Because I'm very excited about it, I want to contribute to it. So we do have a patient error prediction work group that meets monthly on average. And there's a research forum, and if you tag patient prediction, it will end up in our working group. On the wiki of the OHDSI website, you can see more details about our working group. But even better would be if you would really actively contribute to the source code. So, as you know, all the source code in OHDSI is open source. You can just download it on GitHub. We want you to use it, but if you have ideas about new algorithms or feature engineering or whatever, please contribute to that. And if you are a programmer, you can just simply clone our package, and you can add your own stuff and do a pull request back to our repository. So we will definitely take it under consideration to put your favorite model into the whole pipeline, so you can test it at scale that we have been doing so far. I got one question in the break, which I think was a very good question. Somebody asked me if I want to deploy this on my own data. I'm considering to move my data to the OpenCDM. Do I have to put all these tools in the cloud? And I'd like to be very clear that that's not needed. So we here use the example where we run it on a virtual machine, and although it's in the browser, that doesn't mean that it has to be online. For example, in my own database in Rotterdam, where we have a GP database, this whole infrastructure is not even connected to the internet. It's a completely secure environment, but we're still able to utilize all the tools because we can install an internal web server there, and that can run all these tools in your browser. So don't be tricked by that you have to share your data in an internet environment or something. Everything will run in a secured environment. So what will we be doing from now on? We want to increase the number of databases that we run our studies on. We want to do the external validation and many more data sets. And as I mentioned yesterday in my short talk during the symposium, for example, in Europe, we will be mapping many more databases. And I'm very interested how some of these models will be working on our European data and our different data types that we have: hospital data, GP data, claims data, etc. We want to increase the number of cohorts at risk, so the target cohorts, build more models for that, but also more outcomes. And if you've seen that, you saw that plot that I made from depression and then those 22 outcomes, I think what you need to realize is that the average prediction paper is describing a couple of these cells. So it's answering one T and one O question, and then maybe runs that two or three different algorithms in one database. The columns in that picture show that we are doing it over different databases, which has not been published that much. But having all the outcomes and all the target cohorts is really something that will change the way we look at prediction modeling. And we want to extend that whole plot in all directions. So more outcomes, more databases, and in more target cohorts. So this picture that I showed earlier with all the colors was only on pharmaceutically treated depression patients. But what about patients with atrial fibrillation or other type of patients? So we want to build these panels for many more target cohorts and outcomes, a bit like our friends from the risk estimation group did with Legend, where they compared all those drugs. We should actually use all the cohorts that they have created for Legend and try to build prediction models for all these 58 different outcomes that they had in different target cohorts. Of course, we will continue doing a lot of methods research, and that's where my heart is and where I really want to progress in further, thinking about better performing algorithms. Transportability is really high on our agenda because currently we are mainly building models to get high performance, but building models that are well transportable is a different question and may require other types of methods that we have to develop to make sure that our models are transportable across similar databases or maybe other data sources. Temporal information is also a very interesting area. So what Jenna showed was that at the time of risk, we can look back in a time window and say whether a disease had occurred or not, and we can define different time windows. What we do not take into consideration yet, at least in this part of our package, is the influence of order of diseases and how predictable that would be. And I'm personally, I think there's a lot to gain there because there's a reason why you get certain diseases in a certain order, and we should try to use that information in prediction as well. And we started with that with the deep learning approaches, so the recurrent neural nets, if you're a little bit into that. There we can use an extended version of feature extraction where you can have multiple windows that are not overlapping but are just stacked windows in which we can, for example, calculate the average measurement or the last or the first measurement in the window. So we would have all those individual points or conditions over time and use that information within the deep learning networks just to build predictions on temporal data. Another area that we will be going to is textual information. So there's a lot of information in text. And for example, in our database, we have a lot of textual information in Dutch, and we know from studies that we've done on our data that finding diseases, when you try to find diseases, the textual information will help you a lot, and you will find many more patients there. So there's a working group in OHDSI, the NLP working group, that tries to build tools on top of the CDM and on the text table, or that we have an NLP table and that contains source information and one that contains the processed information. Which is a very important area of research. That will also be done in my group. Deep learning, as I mentioned, something that we will look into a lot. We have not answered the question whether deep learning will help in electronic health records or not. I know it's a big hype, but we just have to try it out. And people that are saying, well, I don't know if it works, we don't know. We have to try it. We have to build infrastructure to do it at scale to answer that question. And I really hope that we can contribute to that as well, and I'm quite sure we will. Ensemble training is also interesting, and we have implemented that now in the package. We didn't have time to go through all those different additional features in the package, but on the website or the GitHub, you can find also vignettes dedicated to, for example, ensemble training. This is also an interesting question. If we combine all those individual models and have a super learner on top of that, how well does such a model transport and how well does it perform compared to the individual models? And one of my students looked into that, and we already demonstrated in some examples that the ensemble works better and is also better transportable than the individual models. again, something to look at scale to really answer that question. Learning curves, also interesting. How much data do we actually need for a prediction? So we always say we need more and more data, but it may well be that we already have enough data to answer the question, and just adding more data will just mean we have to consume more computer power and do not improve at all. So getting insight in that, and we started by increasing the training set size and see the impact on test set performance is also, I think, interesting. Also, that learning curves gives you insight in the bias and the variance of the model, and whether you're overfitting or not. It's also an interesting topic. Tool development. So we made a big improvement compared to the last tutorial last year, where we already had functionality to create a Word document with results, which was fantastic. But now with the integration with Atlas, we really take it a step forward, because now somebody can build it even without too much R knowledge. Okay, you still need to know how to build a package, but you don't need to program everything out. Atlas will help you to create that package quite nicely, and especially the external validation package that's automatically created. I think that will be a game changer, because that means that actually is the reason why we could answer that question yesterday across so many databases across the world. Model library. So we've been thinking about how to disseminate our models. So we created a model now. That should not stay on the laptop of Jenna or somebody else who did the study, but we should find a way to share our models on a public environment. So we need to build something where we can upload our models with all the performance measures, and probably something like the Shiny app. Yes?
Sorry, I do not want to interrupt.
Oh, worry.
We, in the process of discussion, and this is starting to be implemented as sets repository based on Athena. We are going to start with concept sets sharing and cohorts sharing, so that everyone do not build like diabetes type 2 cohorts in their own environment, but this idea is extendable, and I also thought of cases like yours, so that we can share models and put some information there, and versioning of the models, and so on, so that we do not only distribute vocabularies like systematically and in a public way, but also distribute artifacts in the same
Perfect.
way. So this work, I believe I'm going to put proposal in a month, in upcoming month, and we'll start working on the deeper start working on the requirements, and hopefully
That's fantastic.
before the European Symposium we'll have something.
Great, because I think that's really something. So some of the things that we can do quickly now is because Jenna or somebody else within J&J has developed the concept set already, or they have the cohort already, and you like to find a way to share that with others. We do have it in Atlas now, but it's not the ideal solution, I would say. And we like to understand how well these cohorts work on different data sets as well. So just only the cohorts is the first step. But having performance measures on that, like instance rate or something, or whatever measure we think of, that would be great. And those artifacts are part of what we do here in prediction. And if we can also move the prediction into that space with things like a Shiny app, where you can just see the performance of the different models of different databases, and that's really going to be have high impact, I think, on what we're doing. So fantastic that you're having that idea, and happy to think about that, of course, with you. Results viewer improvements. So we want to think whether we need to add more things in the viewer, other types of measures. We have smooth calibration. We have other things that we're thinking about. We could extend that a little bit further. It's also an area of improvements, further improvements. It's already great, but maybe we can extend it a little bit. The last point, I think, and that's a crucial one for me, clinical impact on patient care. So we need to. And everything is great that we've built, but now the model that we built, how would that impact patient care? And we need to have maybe another audience or another type of collaborators to see how we can assess that, and people that have experience with putting these models into clinical practice and have ways to evaluate that. We've been talking briefly about that with some people, where we could maybe apply a model in one hospital and not in the other hospital, and the hospitals are quite comparable, and see what the effects are. You need to have some kind of benchmark. measurement, and that may be something that that could help. But it's not easy, and this is also one of the reasons why many of these models do not end up in practice, because we lack that last step, and we need other people that have experience in applying it into a clinical environment to see what the impact is. And if we can show that, then we really make the difference that we aimed for. With that, what was our mission in the beginning, the first slide. So I'm going to end with just thanking everybody, all the faculty, for helping out. I hope you liked it. Please do stay if you want to have some other interaction with us, a little bit offline. Do stay and play with Atlas or with the prediction tools. We do like to hear from you how we can further improve the course, because we get questions or that we can do these type of tutorials across the world, and we will be doing that. Actually, in December, we'll already be doing a tutorial at Oxford University. And there will be more coming like this. So if you can give us some feedback, you will also get an email from Maura with a link to the evaluation form. Do fill it in so we can optimize further and maybe focus differently if you think so. Any questions, send email to me and Jenna, or post it on the forum, and we are happy to respond there and give you answers to your questions. Thanks, and we talk later if you want to.